what you want to do is you want to get this thing that is in your swag bag assembled. If you are like me and basically incapable of using your fingers for anything but typing and holding food, in Switzerland that's really handy to be able to hold food. Traditions and stuff. Anyway, so you can assemble it right now, or you're going to assemble it later when I assemble it in front of you. So gather around, kids, if you need some help tinkering. Right. With that out of the way, so how did this begin? And I'd like to sort of, as this is the last call, I'd like to sort of go back in history a bit. So in 2011 or so, a very, very small meetup group in Erfurt, which is Eastern Germany, where I lived at the time for studies, invited me to speak about some random stuff. I think it was HTML5 as a Flash replacement or something. And that was brilliant, and that got me into into this entire community thing. And then in November, I think, I got an email with the headline, JSConf US last call, speaker invitation. And I was in public, but that didn't prevent me going full bananas about that. So thank you so much for putting up this one. And I'd like to take this opportunity to thank all the communities that I got to visit over the last couple of years, and all the people I met, and all the fun we had, and all the tough decisions and chats we had. And right, with this one, we're going to dive into the actual topic. So we're going to talk about virtual reality. And here are two examples. The woman has fun and is pretty astounded because she thinks she stands right below a chopper over some random city. And then there's this other guy who walks through an apartment that doesn't even exist yet. So you can see from the reactions, at least of the lady, the guy is a Swiss guy, so he has zero facial expressions, just like me. That's not true. Anyway, so it's really amazing, and it actually gets, it sets free a lot of emotions and feelings, because it tricks a very low level of our brain activity to think that we are in a place that we actually aren't. And originally, this demo was designed for a small number of people, because I thought, who's going to have a cardboard? I mean, come on. A lot of people haven't even heard about that. So I tested with 6 people, and it was working nicely. I'm like, I'm done. So I can just, pack 4 cardboards and have a little live demo with a few selected volunteers. Now the situation is slightly different. And let's hope it doesn't end like it ended in the movie, right? So without much more other talking, here is how you assemble this one. Pull it from the cover. It's going to be a bit like these airline dances, right? You pull it out of the cover. You can put the cover away for later reuse of the cardboard device. Open up the lid. That wasn't so smooth, right? And get this flap over. Fold it over, fix it with the Velcro to both sides, take your phone, go to that web address, and I really hope it doesn't crash, or we saturate the entire uplink. And now we get this. So if you can't use your phone, or if it doesn't work with your cardboard device, you can check it out here as well. So we click to start the demo, which connects us to the server. That then goes into loading forever, because we do saturate the upload. Oh God, there's a lot of people already. And you put in the phone in here, and then you can pick it up like that. And ladies and gentlemen, a moment of silence, I'm going in. And there's all the horses. Oh my God. And you can move like, whee! So let's see. Wow, there's a ton of people. Horse.js multi-user! Woo! Hi there, how's it going? Some people are having trouble moving, I guess. Or we're actually screwing up the network. Whew. All right. That was it. No, have fun, but please. So that has been at least 20 people. Wow. Right. So this slide is a bit nice, and it doesn't have a slide. So voila. If it would have crashed, I would have gone like, sorry. So it's really nice because this photo is pretty much multi-purpose. All right, so what is in there? What is behind that demo? Well, first of all, we have to get 3D content on screen. And we're going to use WebGL for that because it's the perfect technology for putting 3D content on screen. And then we have to get this entire sensor thing working. It also works with the Oculus Rift in certain browsers, actually. It will probably work with other hardware as well. It works with the Gear VR theoretically. I haven't ever seen that practically working. And we're going to use WebVR for it, which is a standards proposal or a spec draft that is in development right now. We also need high-speed networking in the browser, and WebRTC kind of comes in handily here. So let's talk about WebGL. What is WebGL? Well, first of all, everything that we're going to draw on screen is made of pixels. In WebGL, because we like to invent new words, we invented the word vertex, and multiple things are vertices because irregular plurals are fun for non-native speakers. So here we see 4 points. These 4 points are not just 2D points, but actually have a Z coordinate that can go into the screen or out of the screen. So it's a 3D point, if you wish. And we have 4 of them. Now, drawing points by themselves isn't very terribly interesting, and actually making surfaces from them is very, very inefficient if you do it in JavaScript. So we have a thing that's called faces. And faces are basically just vertices connected to form certain, well, shapes. Can be quads or can be triangles. Triangles are handy because you can pretty much approximate every shape with triangles. So we have these 2, and we put them into 2 typed arrays. Float 32, so that we have a bit of precision. And we have 2 lists. One is with all our points, and the other one is with our faces. And now what? Well, now we're going to put them onto what's called the GPU, or the graphics card in your device. That doesn't have to be one of these bulky cards. It can actually be just the chip that you have in your phone. So we see blue boxes here, we see green boxes here, and we see red box, 1 red box. The colors mean the blue ones are actually running on the CPU and are in JavaScript. But the first thing we're going to do is we take these 2 arrays and put them into what's called a GL buffer, which is nothing else than a bunch of memory on the graphics card. That's what the green boxes mean. We are now crossing the border towards the graphics card. We can also use this to mine bitcoins. Do other interesting things. Actually, you can't mine bitcoins. I know that I tried, but apparently there's blacklisting going on when you try to do that. And then it goes into these buffers, then go into what's called a vertex shader. What does this thing do? Well, a vertex shader is basically a program that runs on the GPU and is really, really fast and pushes these points around if needed. So for instance, if this point is there and my camera is turning, the point has to sort of move, right? So that's what the vertex shader can do for us. That generates what's called rasterized fragments, or actually that goes into a rasterizer which rasterizes it into fragments. So that's more or less the actual pixels that we're going to color in later on. Now, how do we going to color them in, right? We have to sort of know that. Well, that's what a fragment shader does. It's another piece of program on the GPU that colors in every single pixel using images or using some sort of math, and it's also really fast because it's highly parallel. And that generates this textured piece of concrete wall, not concrete, brick wall. And now the last question, the question remaining might be, what is then this shader code thing? It is code that we can write and upload to the GPU. But we can't write it in JavaScript, unfortunately. We have to write it in GL slang, which is GLSL, GL shader language. It's a C dialect that's used in WebGL and OpenGL. And then we can actually influence this program and write our own Bitcoin mining. Right. But this is pretty wordy and pretty verbose, so there's libraries on top of it. One, as I'd like to sort of push Microsoft's open source strategy. So Babylon.js is a brilliant library and engine on top of WebGL that runs in the browser quite nicely and is primarily aimed at games, but you can do other things with it as well. I think they built a flight simulator in it. And then another one that's quite popular is Three.js. So this is what Three.js does. Three.js pretty much is having the concept of what you would do when you would try to shoot a movie. You have a scene, which is basically just an empty stage. You have a camera that films this stage, high camera, and then you just put people onto, or things onto the stage, and then you have to sort of move them around and stuff. So this is more or less what we are doing here. We have a scene, we have a camera, we have a renderer. This doesn't quite fit the metaphor, but ignore that. And then we have a box, which is a mesh, which basically is a bunch of faces and vertices and textures and stuff put together, put that onto the scene, render it, do it in a request animation frame, and you should get 60 frames per second if you do it right. A lot of people do it wrong, including me sometimes. So besides that, the next thing then would be to go into WebVR. And there's a WebVR.info has a bunch of resources on what you can do with WebVR and how the specification currently stands. It also links to resources on how you can get started. And let's go a bit back in time. Why am I so enthusiastic about WebVR or virtual reality in general? Virtual reality isn't a new thing. I think the first one that I found was, the first research was published in 1962. That was long before I was born, and probably some of you as well. And in 1968, we got the thing on the slide, which is called the Damocles sword. And I find that a very, very well-coined term, because it's kind of cool. But on the other hand, look at it. No, I wouldn't try that one, especially because you can't just, I mean, every one of us nowadays, I mean, this is 1968, everyone has one of those at home, right? No, you don't. First of all, it takes a lot of space, and second, it's freaking creepy, if I might say. It looks a bit like they would be shooting something into his head, whatever. It's horrible, but it was really, really cool, and it was the first head-mounted display for virtual reality, 1968. Then this happened a couple of years ago, the Oculus Rift. This is the DK2, which is currently available, soon to be replaced by the customer version 1 in Q1 2016. So this one, as you might wonder about, this is multi-$1,000s, right? This is really, really expensive. This one is, I think, $250 or $350 right now. But Oculus actually published the specifications, like the requirements and hardware that you gotta have, and they are really, really beefy. Most computers won't be able to. You can't run it on a MacBook. You can't run it off your iMac because they're not going for Mac OS X right now. You can't run it on Linux, which pisses me off. And Debian can do everything, but not VR. Like, what? Actually, it works. Fun fact, it works. Out of the box-ish, if you know the right kernel options. Anyway, so this is $350 plus approximately $1,000 in hardware that you have to get specific for this purpose. Obviously, you can use it for other games and stuff as well, but it's kind of specific still. But then this happened. And I don't mean today, right? So when I ordered my first cardboard from China, it cost me, including shipping, which was free, shipping to Switzerland, that is, $2. I get 0.75 espresso in Zurich for that. So espresso or cardboard? And I said, like, cardboard. And I never regret that. So that's pretty cool. Obviously, it's kind of cheating because you have to have a phone that is capable of running 3D content. So it's not really that cheap, but on the other hand, if you look at it, how many people do have a more or less recent smartphone? How many people do have a dedicated gamer PC, right? So yeah, it's a thing. And actually, we saw it working with, or working reasonably well with iPhone 3G, so that's all right-ish. It's not the same experience as with the Oculus. The Oculus comes with a motion tracker as well, so you can literally have the motion tracker set up like this and then go around things and sort of bow down or try to get up on your toes. You can't really do that with a cardboard because it doesn't have any sense of where in space you are. But to be honest, 90% of the times, it doesn't matter, right? You can do a lot of mind-blowing things without that, and that is amazing, and that's accessible as well. And there's a personal story for me behind the cardboard, which is I have a family member who is unfortunately suffering a pretty extreme case of social anxiety. So he really doesn't get out of the house much. And that's particularly annoying for him because he sees how everyone in the family sort of gets around the world and gets to see nice places and has all these memories, and all we can do is we can bring them back as photos or videos. But the problem with videos or photos is like this one. You stand in front of a flat thing that's more or less static. It doesn't react to you. It doesn't give you the same feelings. It doesn't give you the same experience. I'm not saying that virtual reality, and particularly the cardboard, does give you the same, but it's a pretty good substitute, right? If you can't have this particular thing for whatever reason, physical disability, mental disability, or just because I'm pretty sure time travel isn't going to be around for another 5 years probably. So ancient Rome, hard to get there. Pompeii, before it was destroyed by the Vesuvio, hard to get there. Even actually, the train connection to Pompeii is really bad if you ever plan on going there. So even getting there today is pretty hard. That aside, this opens up this possibility. And I gave him a cardboard, and I took a photosphere. So that's basically a panorama image, but you also do it up and down. So you get a full sphere covering the space around you of a place in Zurich on a mountain. Well, Swiss people will kill me now, on a hill. 500 meters, I walk that home and swim it back. Anyway, I'm not even kidding. I figured this one out this summer, like, oh, it's so hot, I don't want to get into the bus. You don't have to, you can float down the river. Yeah, and I did. And one day I didn't get out in time, and I was there in the stream. I'm like, oh, this is so nice. Where are waves coming from in a river? And while I was thinking about that, the answer made itself very clear. If you don't get it yourself, stones very close to the surface is the answer, in strong current. So yeah, that was fun. And he got on this, he put on the Google Cardboard, and you should have seen the facial expressions. And it was a pure joy, and that got pretty close to my heart. And that's why I really like where this is going. Right, with that out of the way, WebVR with Three.js is not that hard, actually. Other libraries not that hard as well, but you would have to probably roll your own until the libraries catch up. I'm not sure if Babylon has already done the work for VR, but probably they have already. So you get a VR effect, you put in the renderer that you got beforehand. You have VR controls that read the sensor data from your phone or the Oculus position sensor. You update these on each frame, and you render again on each frame. Voila, that's it. And the cool thing about WebVR especially is like VR is a thing for native apps right now and for Windows applications, and there's the Oculus demo where you can meet with a friend virtually and check out Netflix, like Netflix and chill remotely. Netflix and chill as a service, if you wish, and which is the thing probably for 2016. But both platforms, like the Cardboard and the Oculus Rift, share the same API, but the browsers make sure that you have one API that you got to address, and you get pretty much all the hardware done. So it's abstracting away the hardware. It's already available in Firefox nightly builds, and it's available as a very securely distributed Chromium build on a Google Drive. So yeah, I'm the person who destroys everyone's idea of security downloaded from Google Drive. It's really low cost to get into it, so we are actually using it at work and have paying customers for it, which is cool. And the community behind it is amazing. There's a Slack channel that's open for invites. There's a lot of people on Twitter. The website I showed earlier has a lot of resources on how to get in touch with them. There's mailing lists as well, and the spec is being proposed and drafted on GitHub. And as I say, it allows you to reach people on a very, very deep level because it goes far below what we consciously feel and see and think. I've been in a demo where I was on the bottom of the ocean, and then someone asked me to make a step forward, but there was just an abyss in front of me, and seriously, I couldn't step forward. I'm like, my brain kept telling me like, yeah, you know, you are in the room and nothing's gonna happen. But then another part of the brain that I couldn't control went all Gollum and went like, no, don't, it's gonna kill us. So I obeyed and didn't step forward. So that's really cool. And the last thing that we're gonna touch is the third ingredient. Why does it say 2 then? Right, whatever. The third ingredient, AKA 2, because 2 is the new 3, WebRTC. So WebRTC is quite nice because we don't need a server, right? Well, except for signaling. Theoretically, you can do it without a server, but you sort of still have to have a server. So, but still, WebRTC is pretty cool, right? Except you want to do mobile. So yeah, I would have to build a sort of fallback. And as the only fallback option, I would really have WebSockets. So while WebRTC are quite nice and sort of give themselves to this particular issue because they allow me to pick reliable or unreliable, which is more sensible. Actually, unreliable is more sensible for this case because if a package with information of where you look and where you are in 3D space gets lost, it doesn't really matter because there's another one because you're pretty much still moving most of the time. And if you're not, then there's only a very small delta between the two. WebSockets, on the other hand, are kind of TCP-ish, and because they hijack the connection you already have to the web server, the HTTP connection, and they are reliable. But that makes them slower, I guess, and you have to have a central server. If that doesn't make any sense to you, don't worry about it. The only important key takeaway is it doesn't really matter that much for this particular case, but actually if you want something that's really, really, really quick and decentralized, WebRTC is the way to go, unless you have to support browsers that don't play nicely. So how much data do we actually get on the wire? Because for this to matter, we have to figure out how much data we're transferring. So we're transferring positions and orientations, basically, right? So where is the person looking at, and where are they in space? So that's X, Y, and Z, and rotations around these 3 axes. So that's, for instance, these randomly picked 6 floating point numbers. So that's 6 times a float 32 variable, because that's what typed arrays give us. So that's 192 bits, and we run with 60 frames per second, hopefully. And that makes up for 11.5 kilobit per second. I guess we're safe, right? So how about latency and speed? So I measured this one with round trip times, and I figured out WebSockets are actually quite slowish in this or were quite slowish on this particular Wi-Fi that I was on, versus WebRTC, which was really fast because it wasn't really going that far out over the Wi-Fi. So now I proposed a talk that said multiplayer WebVR, virtual reality using Oculus Rift and Google Cardboard and WebRTC. We got virtual reality, we got Oculus Rift and Google Cardboard, and I would have to build a sort of WebRTC implementation including a fallback to WebSockets. Yeah, sorry, I lied. It turned out that WebSockets are actually fast enough for this. So what you've seen is actually not using WebRTC. But it's on GitHub, so feel free to fork it and make it WebRTC, and you get Swiss chocolate sent from me, probably. Over WebRTC, obviously. So how does the code then actually look like? Well, the server doesn't do that much. It has to do 2 things, really. It has to manage the list of players that are available and their state, which means position and rotation, so that it can send this information to the other players. And then the players send updates, and the server basically just broadcasts them to all the other players. And that means we have more or less 4 different messages. We have the player moving, so a player is moving, and we're just going to broadcast that to the other players. We have a player that just joined the game, so we have a connect message. And we have a player disconnect, so a player has closed the website or has failed to connect or something like that. So that's pretty much it. Actually, there's a 4th message now because I know that there's we're going to see why. There's a limit to the number of players in this game. And I'm like, yeah, I have these 4 people up here, and it's going to be fine. And then this happened. And I had to actually use the 4th one to say, sorry, server's full. Try again later on the next JSConf, maybe. And the protocol for efficiency shall be binary, because I don't want to waste space on the wire. So to make it as small as possible, we do a bit of binary packing. So here we have our message format. It has 3 informations. One is the header, which tells what kind of message this is and what player this message sent originally. The player has to be identifiable so that the other players can then update the right player in the world. And I figured out, so we have 4 message types. I'm going to use 2 bits. But the smallest thing I can get in as a type array is an 8-bit uint8. So I got to pack it a bit and just use 6 bits for player ID. Now do the math. 6-bit means I have maximum 64 players. Plenty, right? That's ample players. High more than 64 people. So yeah, that's why we have this additional message that says unused here. So, and then we have a position information and we have a rotation information. We might not fill these in. If it's a disconnect, we don't really have to send a position and orientation, so we just leave them empty, but that's more or less, that's what it boils down to. So we have 6 float 32s and one uint8. That means we have not too much data, but actually there's more on the wire. So this is the WebSocket protocol, and I couldn't be arsed to actually figure out what these mean, but they are on the wire. Right? So that's 16-bit on the wire. That's sort of pad around our actual message. Our actual message is 200 bits long. That means we have 216 bits on the wire. That's 27 bytes in total per package. That's not too bad. So let's look at how that looks in code. Right. So can you read that? OK, sweet. I wasn't sure, so I zoomed in a bit. The server is quite boring. Yeah, here, this is what surprises like this do to you. So this is an Express application to serve the actual web content, like the client application as well. And then it creates a WebSocket server here. And inside there, it loads a couple of modules. It creates the server on top of the HTTP server, because how WebSocket works is you have an HTTP connection. The client asks, like, hey, shall we upgrade to WebSocket? And then the server goes, yeah. And WebSocket magic happens. And we have a player state. This object is basically a dictionary holding all the players that are in the game, and a global counter of how many players we have to assign them an ID. This one just gets a random position in 3D space, always on the ground, starting on the ground. This one makes the actual packet. That's a bit more interesting. So if we don't pass in a position or rotation, we're going to create a default one just to zero everything out. And then we use an array buffer and a data view of that array buffer. The array buffer, because the array buffer is a bit platform specific in how things are getting ordered, but the data view isn't. The data view is actually consistent. And we're going to use the data view to put things in. So first of all, at position 0, which is the beginning of the package, we're going to put in the header. At position 1, which is 1 byte, we're going to put in the X, and then at 5 bytes, why 5 bytes? Well, a float 32 is 32 bits. 32 divided by 8 is 4, so 4 byte per each of those floats. And then we're going to put in position, all the 3 components of position, all the 3 components of rotation, and we're done. And we have a buffer that we can send over the network. This one is a closure that generates a broadcast handler for this particular socket, which is a player and the player object associated to it. And it goes through pretty much all the others. So this is where broadcasting happens. So basically, a socket that's associated with a player sends us some data, sends us some message. And then we go through all the players that we're having. And if it happens to be that the socket of this particular player happens to be the socket that sent this message, we're just not going to send it back, because it doesn't make sense to relay the messages that I send to me, right? That's additional network traffic that we can avoid. And then this one actually sends to the socket a message, which gets passed in here in binary. And that's pretty much all that we have. Here's an initial announcement. So if a player gets, I'm not even sure what this one does, but the comment says what it does. It announces a player to another. Ah, yes, okay, obviously we don't announce the player to the player itself. Doesn't make sense because the player already knows that he has joined the game. We send a packet, which means here we have a connect message, which is just this binary message type that we saw in the slides, which stands for connect. Shift that by 6-bit, making it the most significant bits, the first 2 bits of this on the highest order. And then we send, oh shit, it wraps badly. We send the position, and we send that into binary. So this is the initial message that we're going to have to make that says, like, this player has joined and is now here, right? And then we send to the player that has just connected, we send all the other players' connection positions. So that initializes the game. And then this is the actual beef of the application. So whenever someone connects to this server, we check if we already have 63 players. If that is the case, then sorry, we can't accommodate you, and we send a message with type reject to this particular player and say bye, close the connection so that he can't bother us anymore, and end of story. If that doesn't happen, then we go to the get the current ID, increment the ID for the next player, and here we set up the player object first with the socket that we got, and we generate a random position, so the position gets generated by the server, not by the client when it joins. We send that, we get a broadcast handler, so whenever this new player sends us a message, we're going to broadcast this to all the others. Kind of makes sense. And yeah, if actually the socket closes, which means the player has disconnected, we send the disconnect message to all the other players so they know that this player has been disconnected and remove them from the game world. Then we announce the players to each other, and that's pretty much it. And then we just start the web server and listen, and done. So that's a bit more than 100 lines, but if you would compress that, that's much less. There's a lot of white space and blah. So that's the server side of things. Wow. Right. Yeah, it has to load because it never saw this before. Google Slides, you are so weird sometimes. So on the client, which is the last bit that's left, we have to do a bit more. First of all, we have to initialize everything that's rendering related, right? We have to load the textures, we have to load the horse 3D model, we have to do the actual render loop, we have to receive messages from the server, and we have to send messages to the server whenever we are having enough motion on our end. Because it doesn't make sense to continuously send a message. If I haven't moved, why would I send a message? And that looks like this. How am I doing with time? I have no idea. Probably going to have a couple more minutes. Client. And the client's main logic is a good question, is in JS, exactly. And a bunch of smaller modules. And here what we're doing is, primarily there's a parameter because you might have an older cardboard where you don't have a button, so you can select a different thing, and then you actually get auto move, which means you constantly move around, which is quite handy and nice for people who have the cheaper version of the cardboard. Then we initialize the game world, which does all the rendering initialization, which returns a promise. Once we're done with that, we initialize the network, which opens up the socket and does all the messaging there. And whenever we're getting a motion event from this game world module that's written, and that's a custom module basically that just tracks if the VR controls have updated the position or if I have pressed the button so I move. If that happens, I send a local update with my position over the network. All right. And then we have this overlay that you saw that says tap to start. It requests full screen. It locks the orientation because that's actually an annoying thing. So if you don't lock the orientation and go like this, then it might automatically rotate and look shit, and you vomit. To avoid that, you were laughing, but it's not that much of, well, you can say it's a bucket full of fun, but it's not that cool. So I lock the orientation to prevent that and allow you to sort of do these things where you go into portrait mode as well, which is a bit browser specific, but hey, that's what you get. And then we just start moving if you have to move because you can't press a button. And then there's some event handlers, and that's it for here. So that's not very interesting. So what's going on in this game world then? And that's where the virtual reality things go on. If you're interested in networking, cool, check out networking.js. I'd like to dive into this one. I wrote a wrapper around Three.js because I'm really, really lazy. I mean, efficient. So I don't have to deal with most of the things internally. What I do is and we're going to go through the code as it flows. In init, this one is a little longer, we initialize a world and put the camera in the middle, which is the coordinate origin at 0, which is the z distance. We put up a certain distance until which we're going to render, and then we have a render callback that does the actual rendering. We put a light in so that it's not dark, makes sense, and we put a box, which is this a JS box that you might have seen if you were around that one or floating around the world, which uses the JS PNG file as a texture, which is why it looked like a JS logo as a box. Then we have a sphere, which is sort of the aura around that box. And it's transparent, and it has a pink color, because JavaScript and pink sort of go together. Or yellow, really, but yeah, yellow is boring. Then we have the ground, which is just a plain shape that stretches everything. And then we have a box with a bunch of images around. And that was the sky and the horizon you were seeing. We are faking that. It's not really sort of like there's clouds. Nah, screw that. That would drop your iPhone's frame rate, so we're going to skip that a bit. And yeah, then we just put it into the world. We get a camera. We load the wonderful horse. Look at my horse. My horse is amazing. It's in virtual reality. Woo! So I can fly around with it. And then we just initialize the VR controls and the VR effect. That's more or less it. And in the render loop, scroll. In the render loop, we're checking if we are going. Very imaginative name. And if we happen to be, and if we're going out of bounds, then we sort of make sure that you can't get out of bounds. And we update the orientation of you, and we rotate the power up so that it spins a bit. And we render the scene. And if we happen to be actually moving enough for it to be visible, and we're moving, then we're sort of sending that information or calling this event listener, and the network actually sends it over. And yeah, check out the code. It's quite fun. You can extend it whatever you wish. And we did it. You can totally wire me the money on my Swiss bank account later. So what's next? Well, very quickly, first of all, you can do a WebRTC implementation of that. You can actually build game mechanics into it, because right now it's just fun to fly around with a horse, but not that much, like scoring or something. You can use the gamepad API, which is quite fun as well, particularly with Oculus Rift. And there's things like the leap motion or Maya, which allow you to actually use your hands in virtual reality, which gives a better feeling of presence. That's it. Thank you very much.